Hello there. Let me show you a quick tip on how we did the volumetric light beam at the end. We didn't use any thing really elaborate like scattering or absorption. We used a simple emission shader, and that's just because it's fast to render and it doesn't really produce any other issues. So the first we do is we'll add a cube, and we'll scale the cube on one axis, and this is going to act as our light beam object. We can use any object really, but a cube is just simple because we can see its orientation. And we're going to create a new material on this cube. Right now it's a simple diffuse solid material, and we're going to make a volumetric material out of it. So we're going to add an emission shader, and we're going to pipe that into the volume output. And now you can see if we vary the strength of it, the more dense and the more emissive the material gets. We're going to assign some color to it that kind of looks like a light beam. And what we can do now to control the strength of the emission, we can add an additional texture, a gradient texture in that case. And we pipe the color of that texture into the strength of the emission. But before that, let me just add a texture coordinate node. We'll use the generated coordinates from that object. And now the texture gets projected along the x-axis, and we can change that really easily. But first, let's add a color ramp. This way we can actually control the gradient of that texture. And if we click on that texture and we go to the texturing buttons, we can change the mapping of that texture. So in that case, we have to project it along the y-axis. For the rest, we can just assign none. And now we can control the fall off of the texture more easily. Now, but how do we make it round? It's still a cube. So we're going to add another gradient texture, and we're going to use the generated coordinates again. And this time we'll use a spherical texture, and we'll use a color ramp as well to change the fall off of the texture. And just to quickly visualize, right now the sphere is projected from that one corner here, and we can use a mapping setup for this to reproject it into the center of the object. So let's switch it to texture. And let's change the location to XYZ 0.5, and that's going to flip the volumetric texture into the middle of our object. And now you can see it's some sort of spherical shape. But we really only need two axes here. We need the Z and the X axis because we want to turn it into some kind of cylinder. So we can also switch Z and X on, and the rest none, and that will turn it into some sort of cylinder. Now the problem is that it's not cone shaped, but we'll address that. So now we can mix the gradient, the first gradient, with the spherical texture, or actually it's just a circular texture now. We'll use a math node for that. Gonna switch it to multiply. Now you can see we can control the fall off and the circular shape of it. Now the next thing that we have to do is we have to produce some sort of cone shaped. And really the simplest and the stupidest thing I could think of at that point, I'm not a math person really, is to use the scale of the texture. So you can see if we scale the texture down or up on all the axes, we can shrink it or we can grow it. And really, the best thing we can do is just use two different mapping nodes and control it with that color ramp up there, or actually with the linear gradient that we created in the first place. So we'll create an additional mapping setup here, and we'll scale it down. So now the texture is really small, and we have to blend that with the mapping on top of it. And since it's just a vector, XYZ, that's the same as just colors, RGB, we can use a mix node for that, so we can blend these two vector mapping node setups. And we use this gradient texture up here as the factor input. So we'll move everything back slightly. Bam. Now that doesn't look like a cone, but it gets us close there. So we have to flip these textures, these mapping nodes again, just to make sure that it's all neat and tidy. And again, I'm not a math person. The best thing I could do at this point was just, well, I kind of have to get it into a sort of more linear shape. And the best thing to do, to use for that is using the RGB curves. And we'll just add a point in the middle here and then just crank it down. And that sort of gets us almost there. Of course, the camera angle later on also plays into how the cone looks like. And really, we also have to adjust the size and the scale of the mapping inputs a little bit, because the light source is actually a little bit bigger than what we have here right now. And then we just tweak the curves a little bit to make it fit into our setup. All right, now we have a nice little cone-shaped texture, and the next thing that we can do is, you know how in volumetric light beams or generally in foggy environments, there's a lot of stuff flying in the air. In that case, the light might have been projected through some sort of glass. So we'll use a noise texture to create that sort of light shaft effect. So we can plug the noise texture output into the strength. So I can just quickly demonstrate what that thing is doing. We'll just sharpen the edges using the color ramp a little bit. And we can also project that on 2 axes right now. So we need to try out which axes are fitting for that. I guess it's the same that we did before for the spherical texture. So we use Z and we use Y, no, X, right. All right, and now we just have to use the same mapping coordinates that we used for the spherical texture. And you can see the texture is small on one side and big on the other side. Now we can also multiply that with our spherical texture, and we get a nice and beautiful light shaft. We can play with the color ramp fall off a little bit, and also with the scale of the texture until it fits and it looks somewhat natural. And I can add an additional multiply node at the end to sort of boost the brightness a little bit. And then I can make the first fall off a little bit more natural by using a B-spline gradient. All right, that's looking much better. Now we can also animate the scale slightly, so when the light turns, we actually get an additional bit of movement. And the next thing that we can do is add some kind of foggy atmosphere to it. So we'll duplicate the noise texture, and I sort of have to blend it into the rest now. This one I can actually use another math node. So let me just show you how that looks like here. We'll use another color ramp. This time we'll use all the axes, so we're projected into 3D space. And this will act as some sort of clouds that are floating around in the atmosphere. We'll use a math node, switch to subtract, and we have to make sure that it's clamped. And that will just subtract the noise texture from that light shaft here. Now I just have to make sure that as the light beam is moving, the clouds are actually not moving. They're fixed into space. And for that, I cannot use the generated coordinates, but I can use the world coordinates. And for that, I simply use an input geometry. And from that, I use the position of the object. And I have to bump the scale a little bit for that. And now every time we move or we rotate the light, the texture actually stays fixed. So when we animate it, the shaft looks like it's moving through some foggy sort of atmosphere. And that's how we did it.